It then asks for the angular speed of the drum, right? What's the angular speed of the winch drum? Well, if the winch is, we know that the rope here is moving at 8 centimeters per second here. That means that this is friction and massless. It's also moving at 8 meters per second on this side as well. We know what the radius is here. So the angular velocity of this winch must be equal to its tangential velocity, which is 8 centimeters per second, divided by its radius of this barrel drum. So that's pretty straightforward also. 8 centimeters per second divided by 30 centimeters. We don't even need to convert our units, actually, since they're both in centimeters. And this would give us, oh, what would that be? Something, it would be like 3 3/4, I think. So 3.7, no, 0.375? I'm not doing this well. How do I do math? It's something a little less than a third, right? 10 30s. If we had 10 over 30, that would be 0.3333. So this is something a little bit less than that. So this is, let's say this is roughly like 0.26 or something like that. Radians per second. Right, so that's part C. This was part A. This is part B. And to get to D, D asks, what power must be developed by the motor to drive the winch drum? Well, the power, oh, this is really excellent. The power is equal to the torque times the angular velocity, right? Just in the same way that power, when we consider linear forces, is equal to the force times the velocity. So here we have the torque and the angular velocity. So the power should just be equal to 6 times 10 to the third Newton meters times the angular velocity of about 0.26 radians per second. And we can finish up this calculation and get a numerical value for that as well. So hopefully that's fairly clear. It's pretty straightforward.